So today's topic is about statistics and probability. So again, one important chapter, and mostly we are going to deal with the real life scenario. So each and every problem, every concept here in statistics or the probability, we work with the real life scenario. So children love this chapter. And what I've observed in this chapter means many a times I observed this one, whether the statistics or probability, children are working like applying the formula, writing the formula for the particular thing and substituting the values over there and bringing the answer. So only those way only children understood statistics and probability. This I have observed in many of the observation classes. What do you think, teachers? Are they really analyzing the statistical values or probability? What do you think? Probability means probability of an event equals number of favorable outcome by total number of outcomes. What is what? Why are we using that? Do you think really they are analyzing those values? What do you
No,
think?
at least
Many
for
a times I've
probability they
observed.
will try, but for statistics they never try to connect those things. Just formula, substitution, the table, that's all.
Right. So we have just seen that, okay, they're asking for the mean. So mean means direct method or assume or the step deviation. So whatever the comfortable way, they'll take it, write the formula, substitute, bringing the answer. That is called statistics to them. But it's our duty, we are the facilitator, we have to empower the students. Why are we using that? So what is the use of that and what are the disadvantages? What to be done more? So in that perspective, we have to take our classes and also give more number of the examples, and completely we are dealing with the real life examples. Even if we see the exercise questions in our NCRT, it is everything based on the real life scenario. Each and every question based on the real life scenario. It's really very interesting one, and we have to bring that in such a way. So we'll start the session. The first thing, statistics is a branch of mathematics that deals with the collecting, classification, presentation, and representing the data in the different graphical form, and how to analyze it and understanding the data. And various forms of data representations in the statistics up to ninth level they have done, which include bar graph they have done, histogram, pie charts, and frequency polygons they have done. And class 10 mainly with the measures of central tendency of group data and the cumulative frequency graph. So the key concept of the class 10, collecting, presenting graphical representations and the measures of central tendency for the ungrouped data. And the class 10 concept just continuation of the class 9. So class 9, they have to understand the statistics very clearly. Then only successfully they can do the class 10. So class 10 is a continuation of the class 9 concept. There they'll be learning the measures of central tendency of the group data. So the shift will be there. From the ungrouped data, they will go for the group and they'll see what is the importance of the group data, why to find the mean, median, mode for the group data. In that way, it would have been proceeded in our NCRT book. And the cumulative frequency curves, and that is the one more graphical representation in the class 10 key concept. That is the key concept in the class 10. So main concepts to be empowered in the class 9 and 10 statistics. So what are the concepts we have to instill to the students that we will see one by one. So need of the group data. Why the group data is required? Why we have to make it as continuous? Histograms with an unequal class width. What is that? Why we have to follow the histograms? Frequency polygon histograms. They'll be doing the two graphical representation in the class 9 level. So what is the difference? Frequency polygons and the histograms. Measures of central tendency. What is the meaning of that? Why we have to go for the measures of central tendency? And what are the assumptions we are doing in the mean table? Then mean with unequal class width and non-continuous data. It is also possible. Even if the data is non-continuous, unequal class width, we are able to find the mean. Whereas the median mode, it should be the continuous data and the equal class width. Why is it so? And we are in the class 10 level, we are dealing with only the continuous and the class equal class width. Then this next one, locating the median and the modal class. So how to locate it? What is the importance of that? When to apply mean, median, and mode? Why? What are the disadvantages of the mean, median, mode? and the last one, cumulative frequency curve. So these points to be empowered in the class 9 and 10 statistics. So here in my session also, I'm going to just tell about what to do about these important concepts. So first one is the collecting the data. So we have to tell about what is the data and what are the different types of collecting the data. So we have primary data, secondary data. So by giving the n number of the examples, we have to make them to understand what is primary data and secondary data. Even the class 9, so first we'll be starting with the primary and secondary data, collecting the data. And primary data means data collected by ourselves. Secondary data is information gathered from the other sources. So once we have given this, children should give the different types of the examples. We have to just notice that what they are giving the examples, and the clarity should be given based on the primary and the secondary data. And otherwise, we can give some examples and children should classify that as the primary or secondary data. So that is the first point we should do in the statistics. Then presenting the data. So not only the collecting, just by collecting the raw data, it will not do any information. So we can take some examples, or we can collect the weight of the students or marks of the students, we can write it. So just by collecting, just by writing the numbers on the board, it won't do any proper information. So if you want to get that information from that, we have to organize the data. We have to present in such a way so that we can analyze the data further. So slowly we have to go to the presentation part of the data. So presentation part, the first one is the discrete frequency distribution table. So here the marks and the number of students have taken the particular mark is given, and each and every term to be emphasized. What is meant by the observation in the data? So each and every number in the data we call as the observation. And what is the frequency? How many times a particular observation repeated in the data is called the frequency. The sum of all frequency should be equal to the total number of observations. This is called the discrete data. So that to be told very clearly. Then why we have to convert into the group data? What is the use of it? So we should tell to the students, if we have the more number of observations, that we cannot represent by the discrete data. Even if we do that, it won't do any proper information. Just we'll be writing the n number of the rows. Isn't it, teachers? If we have the large observations, if we represent that by the discrete way, then it just tells the n number of the rows. It won't do any proper information to us. So we're supposed to group the data here. So how we can group the data? When we group the data, we have to choose a proper class with. It cannot be the more number of rows, or it cannot be the less number of the rows. That and all we have to tell here when the children are grouping the observations. Then, if you see the next one, here I've taken this example, weight and the number of students. It is also the grouped table only, grouped frequency distribution table. So here we can tell the example. Suppose if a student with the 45.5 kg. So where we have to include the student, in which class interval we have to include the student, means children will be having doubt. So 45.5 is not there in the class interval. So if you want to represent those kind of the number, we have to convert this group data to the continuous. The first children, we have to make them to understand what is discrete frequency distribution table and the usage of the grouped frequency table. And after that, we have to say why we have to convert that group to the continuous frequency distribution table. So when we convert it to the continuous only, we won't be missing any of the values. So in each class interval, there is a missing part. More than 35, less than 36, that is missing. The next one, more than 40, less than 41 is missing. And more than 45, less than 46 is missing. Suppose the student is 65.2 kg. So where we have to incorporate that tally. So to do it, we have to convert this to continuous so that we won't be missing any of the number. So we should tell that how to convert it to the continuous distribution table. After converting the continuous, please don't tell everything to the students. Let them observe it. Now you tell them, suppose if we have 45.5 kg, where will you represent it? So in two places we have 45.5. So one at 40.5 to 45.5, other at 45.5 to 50.5. So where we have to include, it means we have to tell that we have to include in the 45.5 to 50.5. It is a general scenario, universally accepted. All the lower limits are included in that interval itself, and all the upper limits are included in the consecutive class intervals. Such a way we have designed the frequency table. It is universally accepted. So like that, we have to make them to understand why we want to convert the table to the continuous form. We won't be missing any of the number in that. So whatever the number, we can easily represent in the table. That's what we are doing like that. In two places, the number is appeared, so that what we should do for our convenience, it is universally accepted. All lower limits are included in the interval, and all upper limits are included in the next interval. So that way we have to proceed the frequency distribution table. Are you doing like this? Are you proceeding like this?
Yeah, ma'am. Yeah.
Hmm?
We used to put it like
Right.
that.
So each and everything we
Yes,
have to
yes.
clearly tell, and similarly, what's the lower limit, upper limit, class width. So those concepts we should tell very clearly. The next is the graphical representation. So we should tell to the students, if I give a picture, easily you will be understanding instead of when I tell the 1,000 words about the particular concept, isn't it? So picture, easily they can understand. And also we have seen in the cone of learning, right? When we show something, children would be understanding it very easily, and they can retain it also. 50% they would be retaining when we show something. So that's what we have to show and make them to understand. Still, if we give some experience to them, if they work out by themselves, by experiencing, they would be retaining the concept up to 99.9% level. That's what we have seen in that research of the cone of learning in the third session, right? So the graphical representation is very important. So now the first graphical representation they would be understanding here is the bar graph. So bar graph, when we have to proceed the bar graph, for what type of the data we have to go for the bar graph? For the discrete table. If we have the discrete distribution table, then that can be expressed through the bar graph. Suppose if we want to compare, if we want to compare the results, then we can go for the double graph. If we have three comparison, we can go for the triple bar graph. So like that, we have to tell. And here, the width of the bars to be equal, that we have to emphasize every time. So when we draw the rectangular bars, the width of the bars to be kept it equal, that we have to emphasize here. Then in the class 9 level, we have mainly the histogram and the frequency polygon. So we can take some example and we can see the importance of the histogram. So in the histogram, it is a solid bars. It is a solid figure. So without any gap, we have to draw the bars, and histogram, it is mainly for the continuous class intervals. Histogram means they have to connect with the continuous class intervals, that to be told every time, right? And the very, very important thing, what we have to emphasize in the histogram is area, right? Area of each bars is proportional to the frequency, the corresponding frequency. This point to be emphasized every time in the histogram. The area of the rectangular bars should be proportional to the corresponding frequencies. And what I have seen in the students working part here is they would be writing this discrete way. They'll write here 300 to 400. Have you seen this kind of the mistakes? It's completely wrong. 400 to 500. They won't represent like this. Is 300, 400, 500, 600. Isn't it, teachers? Have you seen this kind of the mistakes? They represent the histogram in the continuous, that is the discrete way. Did you observe this kind of the mistake?
Yes,
What do you
ma'am.
think? Yes, it is absolutely wrong. So it is for the continuous class interval, they cannot represent it by the, just like the bar graph, which is wrong. So that we have to tell, if they write like this, 400 to 500, that is the bar. 500 to 600, that is the bar. So they should not mention it like that. It is absolutely wrong. If they represent like that, we have to give only 0. So we have to make them to understand the histogram is for the continuous class intervals, right? Then the other important point in the histogram is area is proportional to the frequency. So that part we have to emphasize. The next one, the importance of the kink. Importance of the kink, we have to tell here. Suppose if the class interval starts from some number which is away from the zero, more away from the zero, we need not represent the numbers in between. We can give this broken line and then we can start where the class interval starts. So the importance of the kin to be told every time. Then the next is for the unequal class width. Generally, the misconceptions are here in the unequal class width. So what are the misconceptions the children do here and how we have to give the correct clarification we will see here. So we'll take one example. Always start with a simple example so that children would be understanding the concepts very clearly. So here the teacher wants to analyze the class marks of the students. There are 90 students here. And when she's analyzing, she observed that the number of students in 0 to 20 marks and 70 and above, only in these two categories, there are less number of the students. Whereas the remaining category, more number of the students are there. This is what she analyzed and the table is given in the book. Okay. And for this, children should represent with the graphical representation. Since it is a continuous class interval, children know that they have to represent this by the histogram. So when they represent this by the histogram, this is the histogram they would have been drawn. Otherwise, we can draw this kind of the wrong histogram and make the students to understand what is the mistake here. So the mistake here is 0 to 20, it is given 7. That means 0 to 10 also 7 students, 10 to 20 also 7. So it becomes 14 students in this 0 to 20, which is a wrong representation here. 0 to 20 together, it is 7. But here it shows 0 to 10 also 7, 10 to 20 also 7, which is wrong. This is the wrong representation. Similarly, 70 to 100, the last one, it is given 8. And here in the graph, 70 to 80 also given as 8, 80 to 90 also 8, 90 to 100 also 8. So the area of this bar, it is not proportional to the frequency over here. This is the wrong representation. So first you do the wrong representation and tell the students why it is wrong, because they can see here 0 to 10 also 7, 10 to 20 also 7 students, which is wrong. And similarly 70 to 80, 80 to 90, 90 to 100, they are seeing 8 in each category. This is completely wrong representation. So to represent this clearly, correctly for the unequal class width, so adjustment should be done in the frequency. So how to do the adjustment? So for that we have to draw the table and the length of the rectangle, the frequency should be adjusted here according to the least class width. So here the least class width is 10. So if 7 is the frequency for the 20 class width, means what about for the 10? So like that proportionally they have to bring the values for the each and every class interval, right? So 0 to 20 here is 3.5 is the frequency now. It is adjusted. And similarly 70 to 100 is 2.67. So 8 students for 30 marks means what about for the 10? So that they have to convert it very clearly. So for this we have to give many examples. First make them to understand this, the wrong one, why it is wrong. Why here the area is not proportionate to the frequency. Why? That to be shown very clearly. And then tell about the adjusted frequency. So after the adjusted frequency, children would be doing the graph very correctly. So now 0 to 20. So 0 to 10 is 3.5. 10 to 20 also 3.5. Now 0 to 20 here 7. Exactly 7 students are there. Similarly, 70 to 80, 80 to 90, 90 to 100, each 2.67, and total will be equal to 8. So now here area is exactly proportional to the frequency. So this point always we have to highlight here. And in this histogram, the width of the class intervals plays a major role, significant role in the histogram. So give them many more examples, children would be understanding very clearly. Then, so what is the formula to convert this, to do the adjustment of the frequency? So minimum class size by the class size of the class into the frequency. Instead of doing this, this is the best way. So 7 is the frequency for the 20 class width. What about for the least class width? So like that proportionally they can bring the answer. This is the way we have to go about the unequal class width for the histogram. Right? So the next one, what's the next one here? The next one here is the frequency polygons. The next graphical representations here is the frequency polygon. So this is another graphical representation, very interesting one. So this is called the frequency polygon. This frequency polygon we can do with the histogram or without the histogram. So first we have to teach them with the histogram. So what they have to do means they have to mark the midpoint of the each bars. They have to draw the midpoint, connect this. They have to mark the midpoints of the each bars and that to be connected. Since it is the polygon, polygon is the closed region, isn't it? So it should be the closed one. So to get the closed one, what we should do means we have to take the class interval prior to the first one and after the last one. So we have to take the two class intervals with a zero frequency. So zero frequency, it won't affect the data. So we have to make the student understand. So we have to take the class interval before to the first one and after to the last one with a zero frequency. And we have to connect that with the midpoint so that it is closed figure. And this is the polygon. And also we have to insist here that area of the histogram is same as the area of the frequency polygon. Because of that concept only, we are closing like this. Okay, we have to take the class intervals before and the after of the initial and the last so that we can get the area of the frequency polygon. It is same as the area of the histogram. How it is same? So here they can see the rectangles here. So this rectangular area is same as this because they both are congruent. Similarly, this area is same here. So everywhere they can see the congruent triangles. So everywhere they can see the congruent triangles. Therefore, they can understand this part come to here. This part has come here. Similarly, this part has come here. So we can understand area of the histogram is same as the area of the frequency polygon. Surely we have to emphasize about this point. So both are same only, histogram or frequency polygon. Both the graphs it is for the representing the continuous class intervals only, right? But why we are doing the frequency polygon, that is also to be emphasized. So before we start about the there is the frequency polygon without histogram, we have to tell these points. We should say area of the histogram should be always equal to the area of the frequency polygon. So how to go about the next we should do about how to go about the frequency polygon without using the histogram. So without using the histogram, we have to find the class mark for the each class interval. So how to find the class mark? That to be done here. So using the class mark and the corresponding frequency, plotting the points to be done and connecting those points, we will get the frequency polygon. So we can see here it is the made up of the line segments and it is a closed region. So it is called as the polygon. And area of the polygon here is same as the area of the histogram that we have to emphasize. Right? So can you tell me, just why the area of the polygons is frequency polygons are more easier compared to the histogram? What's the difference? For which purpose we have to do the frequency polygons? For which purpose we have to do the frequency polygons? Both are same only, right? We have the two graphical representations in the class 9th level. We have histogram and we have the frequency polygon. Histogram is a solid figure. Frequency polygon is the just connecting that line and getting the polygon, right? So why we are giving the importance to the frequency polygon?
We have to compare for comparison of two.
Right. So that to be emphasized here. So what is the use of the frequency polygon means? If you want to compare the graphs, we can't compare the graphs with the histograms, right? We cannot study about that. So if with the frequency polygon, we can easily compare and we can understand the tendency of the data, isn't it? So that we have to tell to the students very clearly. So in the class 9 level, we have bar graph and the next with the histogram and then with the frequency polygon. So all the graphical representation children should be done very clearly with the concept understanding, proper concept understanding. All right. The next comes here, which is the measures of central tendency. So in class 9 and 10 level, they will be doing the three measures of central tendency: mean, median, mode. So why do you want to study about the measures of central tendency? So every time we cannot go through all the observation of the data, right? We cannot study the all observation of the data. We need some representatives of the data. So using that representative, we can further analyze the data. So to move for the further analyzation, we need some representatives. So those representatives only we are calling as a mean, median, mode. For example, if I want to see which is my best performance, okay, which class has given the best performance. So I cannot analyze all the marks of my students in each and every section. So I need some representative of the each and every class, every section, isn't it? So to observe that representative, we have to go for the mean or median or mode. So like that, we have to understand, make them to understand what is the use of the measures of central tendency. So every time we can analyze all the observations in the data, we need some representatives. Those representatives tells about the data. If I see the average of my class is 79.8%, and that 79.8% tells about the performance of my data, performance of my students. So that representative only we are calling as a mean, median, mode. So what are the how to proceed with the mean, median, mode? Like that, we have to view the formula and the more number of the problems are there that will be worked out. Then this point we have to emphasize, this they have to understand after working out the mean, median and mode problem. So mode is the most frequent data point that they know very well. So which observation is repeated maximum number of times, that is called the mode. And mode exists as a data point. Yes. So mode is one of the values in the data that they have to understand it. After doing mode, median, mean of the ungrouped data, children should be able to understand these summarizing points. First one, mode is the most frequent data point. Next, mode exists as a data point. So if we find the mode must be the one of the values in the given data, right? And it is unaffected by the extreme values. Whatever the extreme values, suppose if I take the class marks of the 20 students and 3 students got 5 marks, 7 marks, 8 marks, and the remaining all the other students having the very good score 75, 80, 85, 90 like that, and the values are more extreme values. So those values won't be affected in the mode. So in the mode, just we are seeing which number is repeated maximum number of times. Then useful for the qualitative data. So qualitative data means, suppose we will be asking what is the favorite food item, favorite ice cream, right? It's the qualitative data. So strawberry, this many students like strawberry. Vanilla, this many students like vanilla. And chocolate, this many students like chocolate flavor. So there we are analyzing about the qualitative data, isn't it, teachers? So mode is the only one thing when you want to study about the favorite, okay, and most opted things, then we can go for the mode. So mode is useful for the qualitative data. So sometimes we can take the survey. So favorite items. So vanilla, who are not like vanilla, like that we will do, right? In class 6 level, we'll do it. Vanilla ice cream, chocolate flavor, strawberry flavor, like that we will write the flavors and we will make the frequency distribution table. That is called as a qualitative data. So if you want to understand the qualitative data, then we can go for the mode. Whereas the median and the mean only for the quantitative data. Mode is for both qualitative data and the quantitative data. And also children should know about that mode may have more than one value also. That they have to understand. Even sometimes bimodal, trimodal, there are like that in the ungrouped frequency distribution table. The next one is a median. So what that median does? So median is a point that divides the whole data into two halves. Okay, so 50% of the value is lesser than the middle one, and another 50% is more than the middle one. That children should able to understand after the understanding of the mode, median, and the mean problem, and may not exist as a data point in the set. So whatever the median value they are getting, that is not the one of the may not be one of the observations in the given set of data, and it is just influenced by the position of the items. Median is just about the position of items, and it won't do anything about the values. So this point also children should understand. It is just influenced by the position of items. So by seeing the position only, we are picking the middle value, right? And not their values. And the last one is the mean. So mean is sum of all observation by number of observation, which is the most stable measure. We want to do the comparison, which is the best class, who did the good performance. We want to do these things, which is the most stable measurement. Then the disadvantage of the mean is which is affected by the extreme values. If we have the extreme values, then you find the mean for that, it won't represent the given data. For example, if we have the 10 students mark and the marks with 13, 14, 15, the other set of the values we have with the higher value 75, 85, 99, 98, 87, these kind of the values, if we find the mean for that, so mean you will be getting somewhere around 40s like that, okay? And the 40 is nowhere representing the data here. So if we have the extreme values, and that is not the correct way. So mean won't help if we have the extreme values. It is not the correct representative that we have to emphasize here, and may not exist as a data point in the set. So whatever we are finding the mean value, that is not one of the observations in the given data, may not be the one of the observations in the given data. So like that, children should understand after we taught the mode, median, and the mean. So these points to be understood. Sometimes we can ask these questions in the true or false and justification of that. The next one about the class 10, which is the group data. So before we start the group, always start with the discrete data. So I have taken the discrete data here and finding the mean using the discrete frequency distribution table. Then we can tell that we have the 30 observations here. So instead of the discrete, we can go for the continuous. So continuous, we have three methods. As we all know, we have been doing it. One is the direct method, assumed mean method, step deviation method. So we'll be doing in the class all these methods. But what point we have to emphasize here is we should tell that here 10 to 25, 25 to 40, 40 to 55. So if we want to find the mean, first we have to find frequency into xi. So how to choose that xi? So xi is nothing but the class mark. So here we are assuming that the frequency of each class interval is centered around the midpoint. The assumption is done here. That point you have to emphasize. So two students means two students have taken the middle mark 17.5. Here 3 students have taken the middle mark 32.5. 7 students have taken the mark 47.5. 6 students have taken the mark 62.5. Like that, we are assuming that all the frequency are centered around the middle value of the class interval. That is the assumption we have done here, that to be told to the students very clearly. So whatever we are working in this direct method or assumed mean method or step deviation method, everything is the assumption based mean only. It is not the exact mean. Okay. And whatever method we are doing, whether it is the direct method or assumed mean method or step deviation method, we will be getting the same answer only. So we can get some data from the students itself. It may be the marks or the height or the weight, whatever it may be, we can tabulate it. From the tabulation, we can do one with the discrete, and converting that to the continuous, we can do with the direct, assumed, and step deviation. We have to emphasize that in all three methods, we'll be getting the same answer. And the most important point is we are doing the assumptions here. So in assumptions, we are taking two students have taken the mark 17.5. Like that, we are assuming and finding the mean. That we have to tell that. And at last, we have to compare the discrete mean. So mean we found using the discrete way, and the mean we found using this direct, assumed, and step deviation method. So when we do that, here we are getting 62 as the answer. Whereas in the discrete method, the answer is 59.3. So 59.3 using discrete, because exactly we have taken 10 got by one student, 36 marks by 3 students. So we have taken the original values and then we have found the mean. So that point we have to emphasize. So this 59.3 is the exact one, not the 62. But sometimes we have to convert the huge observations into the continuous way, grouped and continuous way, so that we can comfortably find the mean, so that we are doing that method. So there we will get only the assumptions. assumptions and we will get the approximate answers that to be told to the students very clearly. Then the next one we have the mode. So mode of the group data. So generally we'll do the mode using the formula, isn't it, teachers? We do like this, we'll do the formula and we'll find which is the model class where we have the maximum frequency, that is the model class, right? That is the model class, and then substitute the values and bringing the answer, and we'll be telling that whatever the answer we are getting, that to be between this class interval. So the answer should be between 150 to 200. So we have to get like that we'll be telling. But what is the graphical representation? Why I have taken the graphical method, even though it is not given in our NCERT book, means once recently I attended one of the CBSE meeting. It is all about the competency based education. In the competency based education, they emphasize this point, the graphical representation of the mode. So why we are getting the formula like this? So how we are getting that means the graphical method of the mode is nothing but the histogram. In the histogram where we have the tallest bar, so that is the modal class interval. In the modal class interval, we have to take the diagonal. So we have to draw two lines diagonally inside the modal interval. You can see here. So diagonal they have drawn here. So inside that modal rectangle, in that rectangle, we have to draw the two lines diagonally inside the interval connecting the upper corner of the adjacent rectangle. So upper corner of the adjacent rectangles are connected where the two lines meeting, okay, that point of intersection. So from the point of intersection, the vertical line has to be drawn. So where it is meeting the x-axis, that point is the mode. So the formula given here is L plus D1 by D1 plus D2 into I. I is the class class width, and L is the lower limit of the class interval. This D1 is what is D1 is nothing but the D1 is F1 minus F0, and the D2 is F1 minus the F2. So that when we rearrange, we will get the exact formula F1 minus F0 by 2F1 minus F0 minus F2. So this we can tell to the students how we are finding the mode. So the corresponding graphical method is nothing but the histogram. In that histogram, we have to take the largest bar, that is the modal class interval. In that modal class interval, we have to find the average of the top, right? Average of the most repeated value, that is the mode. So that we have to emphasize here. So to get the mode, we have to draw the diagonals with the adjacent rectangles, and where the two diagonals meet from that, we have to draw the perpendicular, the corresponding value where it intersects the x-axis. That is the mode. Like that, we can emphasize. Even I didn't do in my class, but I understood this when I was attending that meeting. They emphasize the graphical method. So we can also tell 1 or 2 points about the graphical representation of the mode. Okay, teachers? Yes, are you able to follow? Right.
Yes,
Because we used, yes, ma'am, Uma ma'am, you're telling something. Are you doing this
No.
graphical representation, ma'am?
Yes, ma'am. Yes, ma'am. We do. We did same method.
Same method you're doing, but we don't
Yes,
have in our
yes.
textbook, right? We don't have this in our textbook. Are you doing in the class then?
No, ma'am. I think last previous year, ma'am. 2 years back, I did.
2 years back you did
Yes,
this.
yes,
Okay,
yes.
but I didn't
Last
do
year.
this, ma'am. Really, I don't know this
Mm.
graphical. We know histogram, but the how to get that mode and all, I didn't do in the class. But after attending that COE meeting only, okay, I thought this also we have to emphasize in the classroom. Okay, so this we can try how to find the mode using the graphical method. The next we have the median. So median for the group data, this usually will do it. So how to get the mode, the cumulative frequency part is very important. How to choose the median class means in the cumulative frequency, we have to choose a number which is more than n by 2 value and closer to n by 2 value. The corresponding class interval is the median class. We have been doing this in the class, right? And then give more importance to the ogives. So ogives are the S-shaped curve, and this we can do for the either less than type or more than type. Less than type we go below to above, and more than type from upper to lower. Like that the graph will come. So how to find the median? So this we have been doing it, right? And here we can tell that we can give small hint. No, usually we'll tell how to proceed with less than type and the corresponding frequency. For the low achiever students, what we can tell means, so for the less than type 145, 150, these are all the upper limits we have to take on the x-axis. And for the cumulative frequency, we have to add and get. For less than type, we have to add and get the cumulative frequency. And for the more than type, you have to subtract and get it. So addition is for less than type, subtraction is for more than type. Like this, we can give small tips to the low achiever students, but generally we should not take the class like this. So this convert, if you want to find a less than type, add, and more than type minus. That is not the actual way of doing, and we know how to proceed in the class. But for the low achiever students, they don't know how to get the corresponding cumulative frequency. For them, we can help. If you want to do the less than type, we have to add and bring the cumulative frequency. If you want to do the more than type, you subtract and bring the cumulative frequency. Like that, we can give small hint and the corresponding graph and how to get the median from the graph, and also doing both less than ogive and more than ogive in the same graph where the two graphs are intersecting, that is the median. This we have been doing in the class. Just I would like to emphasize where we are doing, how to go about the concepts. Okay, so measures of central tendency we have seen, right? So we started with the importance of the grouped frequency distribution table, and also we have seen why we have to convert the group to the continuous one, that we have seen, and the importance of the mean, median, mode. So disadvantage here is if we have the extreme values, then we cannot do by the mean is not the correct representative. That also we have understood, right? So mean, median, mode, where we have to do it, why we have to do it, those points we have to tell to the students exactly. See, as you all know, it's one of the interesting topic, right? So dealing with the tossing the coin, picking the cards. Children, they are seeing those things, right? Dice they would have been seeing, coins they are seeing every day, and spinning the wheel, marking the point in the archery, taking the cards, everything they are seeing day-to-day life. So using the day-to-day life, we have to make them to understand probability, and we can tell to the students, this is the one of the chapters in your mathematics textbook dealing with the uncertainties. Up to this, we have done many chapters. Everywhere we are seeing, this is the question, this is a certain answer. So everywhere we have certain answers, but only in this chapter, we don't have the correct exact solution, right? Because we are dealing with the uncertainties. So how are we going to measure those uncertainties? So like this, we can tell the importance of the probability. This is the one different chapter. In all the chapters, you have learned certain values, certain solutions, but now in this probability, you are going to work something with the uncertainties. Like this, we can hook the students to learn about the probabilities. So measuring the uncertainty. Here we have two things. One is the empirical probability. The other one is the classical probability. Empirical probability, class 9, we will be dealing completely with the empirical probability. Class 10 with the classical probability. So the introduction of the probability in the class 9 and 10, we can just bring with the examples. So when you go for the class 9, what I did in my class 9 is, children, tell me what is the chance of getting A1 grade in your next exam? A1 grade in next exam? I have no chance of getting the A1 grade. Some students will be telling, ma'am, sure I'll be getting the A1 grade. And some students quizzing, why? How can I predict those values? Then we can tell the students, see children, you have the previous results, right? See your class 1 grade, class 2 marks, class 3 marks. So you have written the many number of the test. Now compare, suppose if you have written 10 term 2 examinations. In the 10 term 2 examinations, how many times you got the A1 grade? So nearly 8 times. That means the chance of getting the A1 grade in your this examination is 8 by 10. So that is the chance. Like that, we have to estimate it. So by seeing the result, we have to estimate the probability. So like that, we can give the examples in the interesting way, and we can make them to understand. If we have more number of the boy students, then we can talk about the IPL matches. So could you tell me, when the Gujarat Titans, what about the chance of winning the IPL by Gujarat Titans this time? Then they would be assessing. So Gujarat Titans with the Rajasthan Royals, so how many matches they played yearly? So in the particular ground, how many times they played and how many times Rajasthan Royals won. So by seeing the previous result only, they are bringing the estimation of the chance of winning. So like that, we can give more number of the examples make the class interest. Just talk lively in the probability class. If we have the more number of the boys, then we can talk about the sports, and from that we can bring the interest. And if we have the girl students means we can talk about the bangles, accessories, like this we can talk, or we can tell about the chocolates, ice creams, they fond of that. So using that we can talk about the probabilities. Children surely love the concepts. And the class 10, we have to tell why we want to study about the theoretical approach. Okay, so we should tell every time we can't do the experiments. Suppose launching the satellite. So how many times satellite failed to launch? So those experiments are not feasible to do it. Suppose in the earthquake, how many buildings are collapsed? So those kind of the things, it is not feasible, and sometimes it may be more expensive to work about it. So experiments are not possible every time. So that we have to understand the probability in terms of theoretically. So, and also we should tell that tossing the head. Many mathematicians have done the tossing head, probability of getting the head, called Pearson's. There are many mathematicians, they toss the coins for 1,000 times, 5,000, 7,000 times, like that they have tossed. In all those experiments, what they have found means probability of getting the head is close to the value 0.5. So intuitively, we can understand that if we're tossing the coin for some millions of times, we can understand that that value will be closer to the 0.5. Like that, we have got the theoretical probability. So every time experiments are not possible, we can't work with the result. Sometimes we have to expect the result by seeing the experiment, by seeing the scenario. So that way we have to give the importance for the class 10 probability. So surely when they come to the class 10, children should understand what is the experimental probability and what is the theoretical probability, why we have to do the theoretical probability. Like that, we have to give many number of the examples. We have to make them to understand and the importance of the empirical and the classical probability. And there are n number of the case study questions based on the probability. And please give it, children would be understanding and they will enjoy when they do the probability, because there are very less calculations, isn't it, teachers? Probability is just writing in the fraction format. Easily they'll understand because they know about the tossing the coin, throwing the die, taking the cards, picking the balls, spinning the wheel, everything they know it. Like from that only we are framing the questions. So it is one of the interesting chapter and also easily they can understand it. N number of case study questions are there, and the assessments. Assessments of the probability is very simple. We can do the slip test and we can give the oral. Oral we can ask in the probability so that we can cover n number of the concepts, n number of the different types of the questions when you work with the oral, right? Suppose we can take one scenario, spinning the wheel. So what is the probability of getting 4 in that, getting odd numbers, getting even numbers, getting prime numbers, getting composite numbers, getting square numbers, getting less than 4, more than 4, not less than 4, not more than 4, like that. With one question itself, we can ask the n number of the questions. So like that, we can cover the complete oral type of the questions and we can cover all different types also. Isn't it, teachers? Like that only I used to do. So I will take one scenario. With that one scenario, I'll be posting all the questions. It's like a quiz. I'll go with the quiz only in the probability. So once I taught the main important concept in the classical probability, what about experiments? What is a random experiment? What is biased, unbiased? Then outcomes. What are the outcomes? Sample space. Then we have to tell about the events, different type of the events, and impossible event, sure event, equally likely events. And we should tell that here we are dealing with the equally likely outcomes. So what is mean by equally likely outcome means chance of getting each and every outcome is same. That is called as the equally likely outcome. So mostly you'll be dealing with the tossing the coin, throwing a die, getting the cards, taking the ball, spinning the wheel, like this question only we'll be doing. So in that way, first we have to familiarize all the terms in the probability. Okay, and starting from experiment, random experiment, event. In the event also we have elementary event, compound event. So that we have to tell what is it, and sum of all the probability will be always equal to 1. So everything we have to tell very clearly. We have been doing, just again I'm telling what to be emphasized in the class, right? Then in the class 10 level, they should differentiate this. Experimental probability is found by repeating an experiment and observing the outcomes. From that, we have to write the probability of an event. That is, number of times the event occurred by total number of trials. Suppose if we take this example, a coin is tossed 10 times. In that, head is recorded for 7 times and the tail is for 3 times. So from this, we are estimating the what is the probability of getting head, which is 7 by 10. Probability of getting tail is 3 by 10. And also we should tell that getting head, non-getting head, they both are complementary events. So some of the complementary events will be equal to 1. But because in higher level, they'll be doing with the non-mutually exclusive events. Here in the class 10 level, we'll be dealing only with the mutually exclusive events. So disjoint events only we'll be having. So we can comfortably talk about the complementary events, and some of the complementary events, the probability sum will be always equal to 1. That to be emphasized very clearly. Whereas in theoretical probability, here we won't do any experiment. It is just the expected value only. So in the coin, there are 2 outcomes, head and tail. Out of the 2, we are looking for the head. So chance of getting head is only 1 head is there. Therefore, the probability of getting head is 1 by 2. Tail is also 1 by 2. So that is the difference between the experimental probability and theoretical probability. Like that, we have to give n number of the examples. Similarly, here, rolling a die for 1000 times, 5 appeared for 140 times. So what is the probability of getting 5 in the next trial? So getting 5 probability is 140 by 1000. And here, whereas in the theoretical probability of getting 5, so there are 6 outcomes. Only in the one phase 5 is there. Therefore, 1 upon 6. So 1 by 6 is the theoretical approach and this is the experimental approach. And when we do the same experiment for another 1000 times, we may not get the same answer. That also we should tell to the students. Then similarly, the other examples I have taken, same with the tossing the coin. Here also, one experiment, tossing the coin for 10 times, 3 times head appeared, 7 times tail appeared. What is the probability of getting head, tail, like that? We have to go for the experimental and theoretical. In class 10 level, children should know to differentiate both experimental and theoretical probability. Then the most important thing is the values of the probability. Many times we have been noted that probability value children will be writing with the improper fraction, right? Improper fraction or the more than one value. It's wrong. Why it is wrong means we should tell that always we are writing number of favorable outcome by total number of outcomes. So total outcomes we are writing at the denominator. So we will be getting always the proper fraction as the answer. If it is an impossible event, 0 is the probability. If it is a sure event, 1 is the probability. For each and everything, we have to give the proper examples. Children will be understanding, and also about the complementary events, probability of getting an event and probability of not getting the event. The sum will be always equal to 1. So mainly we'll be dealing with the tossing the coin, throwing the die, and getting the cards from the deck of cards. Like that, we have to give many examples. And when you're dealing with the cards, we have to say what about the different symbols over there. And I mean, there are 2 black symbols and 2 red symbols. What are the cards in that? I think we have been doing it, isn't it, teachers? So what we have in that, first we have to explain. So using that, we can ask the n number of the questions based on that. Then this has to be told very clearly. So what is the impossible event? So we can take one scenario and we can tell that. So of course, if you're throwing a die, what is the chance of getting 7 when you throw a die? So 7 is not possible. So that is the impossible event. The probability is 0. And when you're throwing a die, I want the number which is less than 7. Yes, all the numbers are less than 7 only. 1, 2, 3, 4, 5, 6, everything less than 7. So it is a sure event, certain event. Then when I'm throwing a die, I want number 1. So number 1 is only 1, we have number 1. It is a less chance of getting. Okay, so 1 by 6 is the probability, is unlikely. And the other one for the likely, it is the most favorable event. Suppose in a bag, you have the 2 colored balls. One is the blue ball, other is a red ball. There are 4 blue balls and only 1 red ball. What's the chance of picking a red ball means? Sorry, chance of picking the blue ball, it is more likely to come because more number of the blue balls are there. So probability of getting the blue ball is 4 by 5. So more chance to get the blue ball. So it is the likely event. So what is unlikely, what is likely, and what is equally likely. So when we throw a die, getting the odd number, getting the even number, both are equally likely events. Like that, we have to tell each and every terms correctly with the proper examples. So these are the things we have to understand in the probability. So up to this, we have seen what is the classical probability and experimental probability. Why we have to do with the classical probability? Because few experiments are not feasible and also very expensive. So we have to go about the classical probability and how to write the formula, and with the different examples we have to make them to understand. Even the values are so important. Probability values always lies between the 0 and 1, that to be told very clearly. So these are the things we have in the probability in class 9 and 10. Class 9 completely dealt with the experimental probability. Class 10 is all about the theoretical probability. Isn't it, teachers? Anything you want to add here before I start the next one?
No, ma'am.
No, ma'am.
Right? So we are doing like this only, and everywhere we have to give some examples and proceed like this. Okay. So now the next one, I have one case study question. So case study questions are very important, and it just enhance their knowledge and also touch always the higher order level. So case study questions are so important, and here the multiple things are there. One is the spinning the wheel, and also they are talking about the throwing a die. So if you see this question, a game at a stall in a New Year carnival involves spinning the wheel first as a first step to complete the game with certain rules. If the wheel stops at a particular number, then the player is allowed to roll a six-faced unbiased dice. So the two events are talking. One is the spinning the wheel, the other one is the throwing a dice. So the rules of the games are given. From that, the questions are posed like that. There are many questions, interesting questions are there, and this should be emphasized here in the probability. We have been doing, again, I've told what way we have to proceed and what are the points we have to empower in the class 9 and 10 statistics and the probability. It's a real life scenario. All the concepts are based on the real life scenario. Even each and every question in the textbook, that is the case study questions only, right? So from that we can build the many new case study question to enhance their knowledge, enhance and also touch the higher order level thinkings, right? So next, what I'm going to show it to you means, let us know about the new app. I found this very interesting, and I'm using this also. So what is that app? This is called the homework app. Are you using this? Anyone? Homework app?
No, ma'am.
No,
No,
ma'am.
ma'am.
So
Myself,
what about you are
myself,
using,
I
Mama?
used. Yes,
Yeah.
ma'am. Yes, ma'am.
Yes, it's really very interesting. Isn't it, Mama? Can you tell about this app? What's the interesting fact about the app?
Ma'am, I can during the online session, ma'am. That is very helpful for me, ma'am. I can prepare that MCQ from the app, ma'am. And then
And
give
even
it to our children. Yes, they are
it is useful for the question
eagerly.
number setting. Right.
Yes. I
Right.
passed to my colleague, those who are handling 10th standard, they are using very much. Ma'am.
Yeah.
Pratima
So-
ma'am and surely, yeah, they are using very much. For
Right.
10th standard. Yes.
Yes, ma'am. Yes, ma'am. So just we'll see about this app. I found it as very interesting. Interesting in the sense we can easily give the questions to the students, because when you want to give some extra question, it will take some 10 minutes time to copy the questions in the classroom, right? We'll be wasting the 10 minutes. So in those 10 minutes, we can just discuss some other new concept or the new way of doing that. We can utilize those 10 minutes. So what this app actually means, in this, pre-typed questions are there from R.D. Sharma, R.S. Agarwal, Oswald, and many different books are there, and pre-typed questions are there. So you have to just go through it and pick the question, okay? And pick the question, and that we can give it as a homework. And it is free for the teachers. And it saves time in the homework creation or assignment. Even the correction also can be done. And the MCQs are auto-checked. When you give the MCQ questions, when the children give the correct answer, it will be auto-checked by the app itself. We need not cross-check anything. And we can share the homework very easily through the WhatsApp group, or if we have the Google Classroom. And anyway, now we are in the physical class session. Physical class session also we are maintaining the WhatsApp group, right? So through the WhatsApp group, we can send the questions. So easily children will note down the question and we can do it. Children can do it. Then currently available for the CBSE 1st to 10th for the max, science, English, and social science. And here it has many sample papers for the CBSE term 2 in the PDF format. So we can take it and we can send it to the students. Okay, so let me show about this app.